All right, so here we have a Rubik's Cube.
Yep.
All right, so pick a move on the cube that we could call A.
So let's say moving this top face clockwise.
Okay.
You can call that A.
All right, and what's A inverse going to be then? Can you tell me?
So you have A inverse is going back.
A inverse is going back. What if you did, what's A inverse starting right now? Going the other way, okay. And what, so we're going to call A is moving the top clockwise in the camera? Okay, great. What do you want to call B?
How about B is moving this here. B is moving this down.
Down.
Okay.
And then B inverse would be coming back up.
Okay.
So like this.
All right, so moving this side down is B, and moving this side clockwise is A.
Okay.
Now, do you think, in this case, I want you to think of this ahead of time before you do it, do you think A, then B, then A inverse is going to be the same as B?
No. I don't.
What do you think?
No, I do not.
All right, why not? Why do you think that? We're not going to get B.
Well, when you move A, it's going, then this, like say this block here is going to be moved up by B. It's not going to be affected by the rotation back of the inverse.
Okay. What do you think?
So yeah, because when you move B here and when you moved A, it's different cubes, and the A inverse is not going to get it back to where it started.
Okay. Well, let's see. Why don't you do A, B,
Keep this down.
A inverse.
So we're not back to where we started.
What do you think?
It's not to where we started.
Okay. And how would you solve the cube from here?
So you could do everything in reverse. Do A inverse.
Very normal A.
Normal A, B, A inverse.
Okay.
So regular B would be this, but this is not the same as what we did.
Not the same as what we did. Okay. Now I want to show you something that we may or may not have found on the when we were looking on the chessboard. When we were just doing the left and right movements, not the reflections, if we just kept doing A, B, A inverse, and we were just getting B, and if we just kept doing the same thing over and over again, we would never get back to where we started, right? Because we would just keep moving B every time.
Yeah.
Just going up and up and up. But I want you to do A, B, A inverse here.
A, B, A inverse.
Now keep doing it.
A, B, A inverse.
Okay.
A, B, A inverse. A, B, A inverse.
So how many times did we have to do it?
4.
4.
4 times, and we got back to...
Where we started.
Yep.
Huh. Isn't that interesting?
Yeah.
Oh, I suppose.
Well, it should be the same as, because A, B, and then A inverse will A inverse and then start the next segment A will cancel each other out. So essentially what you're doing is just doing A, B, and then keep doing that over and over.
And I guess because you're doing A and then B, and then you're doing another 2, 3, 4, and then your A inverse at the end is not an A inverse that gets canceled out.
Interesting.
So the A and the A inverse at the start and the end cancel each other out. And you're basically just doing 4 B's.
Aha. So in a sense, it was a lot like what was happening on the chessboard where
But
we
you
just kept doing
had
B's.
to do it multiple times.
Well, but if we did it multiple times on the chessboard, we just kept walking away.
Yeah.
Yeah.
But you both noticed here that if we did it multiple times, you just kept doing B's, just like before. But what's going on with B here?
It does get you back to where you started. B goes in a loop.
B goes in a loop.
Yep.
Isn't that interesting? So this is something that mathematicians study.
Yep.
And you can talk about doing these actions one after another on things other than numbers. And sometimes you get surprising results. Sometimes they don't behave at all like numbers. We saw the reflections kind of walk away or not behave like numbers. And we saw a Rubik's Cube not behave like numbers, but actually get back to where it started somehow.
Yeah.
It's neat.
That's pretty cool. So yeah, I thought this was a fun thing to share and a neat idea I saw from Alice and Krantz. Good work, guys.